Hi everyone. So now we're going to talk about the formwork and the related issues regarding the formwork for the construction of the column. This is Engineer Omar Ali from Project Management Simplified. Okay, so we have the formwork. We said before that we have finished the steel reinforcement and we need to put the formwork now. So we can see that the formwork is consisted of plywood. This is the plywood, and we have the timber also. This is for the support of the plywood because the plywood it gives the form of the concrete, but it cannot support or it cannot resist the heavy pressure of the concrete itself. So it needs these uh, pieces of timbers in specific intervals to support the plywood itself. So also you can see here we have these ties that is coming around the column itself, around the shutter of the column. And these ties, if you can see here, that we have the first one, the second one, the third one, then afterwards it will become, the space will become bigger and bigger whenever you go up. Whenever you go up, because this is normal, because the pressure here in this point, in the base point, will be so much more than the pressure at the top part of the column. So we have these two parts. We have these two parts, for example, this one, and you can see here that we are using the steel rods here to to support this column from this side to that side, and we have here we have the net, so we can support the column. Okay, the other thing is that we need also for the support of the column, we need these breakers, or we can use these jacks, and it can be adjusted from this point. You have to hammer this at this point, then afterwards this is the screw, and you can adjust your column in order to keep the alignment after you pour the concrete inside the column, because after pouring the concrete inside the column might go here this way or that way. So we need to support the column from all sides, from this side, from the four sides of the column. The other thing we want to talk about is the plumb. In fact, here they are using this binding wire, which is not acceptable. You have to use this one, and this one has to be checked from the point here, from the plywood. We have to check the distance. It has to be all the same distance until we get all the same distance from the four sides. This way the column is aligned and is vertical 100%, and we have to check this one continuously while pouring the concrete to check whether the column is leaning to one of the sides. If the concrete while concreting the column, we have discovered that there is some variations in these plumbs. We have our carpenter here available at the site, and he has to do his adjustment before finishing the pouring of the concrete. Otherwise, the column will be not aligned and will be not vertical 100%. So this is very important also to take in an account while checking, while pouring the concrete. You have to continuously check on these plumbs. So these plumbs, you use it and check it for the verticality of the column for the beginning, for the formwork, before you pour the concrete. Then afterwards, when you pour the concrete, you have to also to continuously, as we said, check on it in order to make sure that the concrete is still vertical. Sometimes here we have holes in the plywood, and this one, because this plywood is not new and it's already used in some in the other places. So these holes, it needs to be closed before pouring the concrete. Otherwise, you can see that the grout of the concrete will come out of here, and the concrete and the column face will be not smooth. It's very important for the quantity surveyors to calculate these overlaps, because it's very important these overlaps are repetitive in each level of the column. If you neglect this one or skip the calculation of these overlaps, you will lose some quantity of your steel, and your calculations will be almost inaccurate, because some of the students, they think that if they want to calculate the main steel bars height, they need to calculate only the clear distance from finish to finish, from slab to slab, which is not practical, because you can see here in this column that we are having here this extra, which is the overlap, or the starter bar, and again we will have it here. So this is very important to take it in your calculations. Thank you very much. Now he's using the vibrator. Now they started to pour the concrete for the columns before the PCC. Now he started to pour the concrete for the columns, and this is the vibrator. And he's putting the needle of the vibrator inside the column to vibrate the concrete in order not to have like honeycombing, and to distribute evenly the concrete in the column. Especially because there is a steel inside the column, so maybe the steel might be an obstacle for the concrete, the aggregate, and all these things from going smoothly inside. This is why we are using the vibration for this concreting process. Now the pump is moving to the PCC. Now the operator is cleaning the pump from the concrete that is inside the pipe of the pump. And this concrete almost 1 cubic meter, so the quantity surveyor who wants to request the concrete, he has to take in account that there is 1 extra cubic meter has to be pumped in the pump hose. And this is why, for example, if you want to request like 5 square meters of concrete, you have to add 1 square meter. This is 1 square meter extra is for the pump itself for cleaning, and it will be excess concrete that will be poured outside the place that you want to pour concrete in. Here the engineer decided to pour this concrete not on the ground to waste it. He decided to pour it in one of the PCCs. After a few minutes, the other mixer machine will come with the new concrete, and will continue pouring the concrete here in this place.